Hello everyone, this is Dr. Vaughn. I am going to redo a video because I actually made a mistake for problem 17.6. So this is the problem right here. There's a first part of it with some contextual things on the top of the previous page. But the important thing is we're trying to create an Anova, and we're doing Anova with repeated measures. So we have 8 different subjects, and they took this, they did these 4 different workshops numbered 0 through 3. And so here's all of the data that we're going to use. But they gave us a head start. They gave us the sum of the squares between, within, and total over here. And we need to do an Anova table for repeated measures. So the Anova table with repeated measures looks very much like the Anova table for one factor, except you split the within variance into a subject variance and an error variance. And so we're going to start by filling out the sum of the squares that's given to us in the stem of the problem. So we got the sum of the squares between 154.12. We'll put that here. We'll put the within variance, which is given to us as well, as 132.75. And we'll enter the total variance, the sum of squares between, which is 286.87. All right, so now we want to compute this, we want to split this 132.75 into the subject and the error. So to compute the subject sum of squares is where we're going to use these totals that they did over here. So we're going to take each of these totals. There's a formula. If you scroll up in the book a little bit, you can find it. But the formula for the sum of the squares is just involving these numbers over here together with how many factors we have. So we're going to take 14 squared divided by 4, 9 squared divided by 4, 11 squared divided by 4, 19 squared divided by 4, 23 squared divided by 4, 28 squared divided by 4, 18 squared divided by 4, and 16 squared divided by 4. Square before you do the divided by 4, add all these things up, and then you're going to subtract g squared divided by the total number of data items that you have. So we're going to take 138 squared divided by 32, and we'll take the difference between the sum of these squares divided by 4 and this square divided by 32. So I did that. I have it written down on a piece of paper, and I calculated it just using a regular calculator, and I got 67.875. Now, to find the sum of the squares error, the easy way is just to subtract these two things from each other. 132.75 minus 68.875. And I can do this by hand, but I can also just use the built-in calculator here in Excel. Again, there's nothing special about Excel. It's just as easy to punch this on a calculator. So there I get the 64.875. These will match what are in the back of the book up to rounding. So they round this to 88, and they round this to 88, I think. And that's going to create a little bit of a difference when we go to compute eta squared here in part B. All right, the next thing we need is the degrees of freedom. So the degrees of freedom works like this. For the between, we're looking at the total number of groups that we have. So that's 4, take away 1, so that's 3. The within groups, we're going to take the total number of data items that you have, 32, take away the number of repeated measures that you have, which is 4. So 32, take away 4, gives me 28. And then at the total, we're going to just add the 3 and the 28 to get 31. It's also the total number of data items, 32, take away 1, just like always. And now the only thing we have to do is split this 28 degrees of freedom into degrees of freedom that can be attributed to the subject and degrees of freedom for the error. And so the subject degrees of freedom is just the total number of subjects that you have minus 1. So there's 8 subjects, take away 1, so that's going to be 7. And that means that this leftover number of degrees of freedom for the error has to be 21. Because again, these have to add up to be the total degrees of freedom for the within. All right, now we're ready to compute the mean squares. And the mean squares is just the quotient of the sum of squares and the degrees of freedom. But the only two mean squares that we need to compute is the between. So again, I'll just use the built-in Excel division feature. But you could just as easily do this on a calculator and type this into a table in a Word document, something like that. So here's that 51.37, and then I need the mean squares for the error. So I'm going to take this equals 64.875, and I'm divide by the 21, and this is where I get the 3.089. And finally, I'm going to compute the F-statistic by taking the quotient of the mean squares between and the mean squares in. And once again, I can use the Excel feature. So equals this number divided by this number over here. and get our F statistic of 16.62952. All right, so then, that's not the end of the Anova test, but it's at least the end of the creation of the Anova table for part A of this particular problem. Of course, the next thing we'd want to do is find the F critical value and then compare our observed F statistic to make a determination about whether we would be rejecting the null hypothesis or not. In this case, that's a pretty big F, and so I'm fairly confident that we would be in the rejection region with that F. Remember the average, the big hump on the F statistic is right at 1. Okay, next we're going to compute in part B the eta squared. And the eta squared is going to be the numerator is going to be a sum of these, it's going to be the sum of the squares between, and then the denominator is going to be the sum of the sum of squares between and the sum of the squares error. So to compute eta squared, I'll just do equals, and on the numerator, I'll take the 154.12, and then I'll say divided by, and I'll put a parentheses to make sure I add the other two things together in the denominator. So 154.12, and then plus the sum of the squares of the error, which is right here, and then close parentheses, and there's my computation of the eta squared, 0.70376. All right, and so I'm going to end this video now, and in the next one, maybe we'll have time to go over the Tukey's HSD. The one thing, if you want to get started, is that we're going to use the K equals 4 and look up this number, this Q number, in the table that's at the back of the book. All right, I'll talk to you next time.